Hello YouTube, I Fix It All here, Team I Fix It All. I got the cover off of my well house. That must mean something. Been doing some troubleshooting. Well, complete with a mouse nest. Got my power that comes in and goes to my pressure switch, and then comes out of the pressure switch and goes into my external control box. Then it comes out of the control box and goes down to the well pump. This is kind of DIY for people. If you need to know a couple of things about it, complete with spider webs and everything. By the way, if you ever fool around with pressure switch, do what H2O mechanic says. I better get rid of this crusty old board. Hang on. Totally dry rotted. Good God, it just broke up. Stays kind of dry in here. I've had the lid off for a couple of days. I don't want to touch that mouse nest yet. Got a little light bulb in here to keep this elbow warm in the winter time. I just screw the light bulb in. So for your pressure switch, right here, here's the schematic again. Power comes from the house, and in my case, goes up into a junction box because I installed this a while back. Comes out of the junction box. So power comes from the house to the pressure switch, and if you have 240 volt, you land one hot leg on one side, because these contacts are common over here. They're common. 1 point electrically. Just land your one hot leg here, and your other hot leg from the house here on the last screw terminal. That way you can always do that. You can remember your two outside legs are coming from the breaker in the house, and the two inside legs, which is 120 volt and 120 volt, travels and goes over into the control box. If you want to check your pressure switch, right now mine's calling for pressure, but use the cover to move the contacts. You just reach in there like this, and you can move the whole gang assembly. You get in there with a fingernail file that you robbed from the wife, and slip it in there and let it close on the file, and then begin filing so you can match your contacts to each other and clean them up. And on your control box, if you have the QD type made by Franklin Electric, there's other types that look just like it. Take the screw out and remove the cover, and it reveals nothing but a terminal strip. It's kind of safety designed, whereas when you take this off, your pump is no longer energized. Make sure your breaker's off, of course, but what we've got here is power coming from the house, line 1 and line 2. Well, it's not coming from the house, it's coming from the pressure switch. And it travels through this screw terminal, and then there's a female receptacle that's made to receive these little tangs. And these little tangs here are the same point electrically, because it loops through the plastic and comes up, as an example where the blue wire is. If you flip it upside down, that blue wire would be the black, line 1. The yellow wire right here would be the white, line 2. So that's power input. And there's your ground terminal coming from your pressure switch. So now we've got this device. On this particular device, we have a start capacitor and a very complicated relay that's made up of a coil right here and a triac And look, you can Google what a triac is, T-R-A-I-C. But across the coil, there's also a read switch. It's a thermal type device. But when you read across the coil, you should have continuity. When you read, you can now assume this is the contacts side. So if you read from here to here, on this blue type of relay, you're going to read nothing, zilch. Well, in my case, I'm reading something, which is like 10, 12, 14 meg ohms. Now that might sound close enough to open circuit. And I'm not saying it's a normally open relay. I'm just saying that you're supposed to get an open condition here. There's another type of box that has a white relay. When you go across the contact side, you have continuity when it's de-energized. And I've got one of those in the garage. And then if your meter will do microfarads, this is a, let me double check something here. Yeah. This is a, I forget how many microfarad that is. A 105 to 120 microfarad. Yeah, that's what this one is. I was reading it with a meter, that's why it's unplugged. But anyway, I'll just leave it unplugged. So I've got a new control box, and as soon as I installed the cover on the new control box, my pressure switch engaged and a relay clicked. Well, no, my pressure switch didn't engage. My relay clicked on the inside, this relay here. That's on the new box. On this box, this relay is not clicking when I give it power and when I turn the breaker on or off, this ain't clicking. Right now I'm in a state where it's calling for water and the pump isn't running. So now you move on to your resistance of your well pump, and you kind of got to Google this, but I had trouble because I'm a 3-wire, but I don't have a ground. So I don't have a ground conductor. I can't find any instructions on a 3-wire without ground. But what I do know is that you read from the yellow to the red, and you're going to have a certain resistance value. And then if you read from the yellow to black, it's another resistance value. Let me get those for you. Hang tight. So here's my new control box here. It's got a smaller capacitor, 86 microfarad, and it's got a different kind of relay. But on this relay, when you go from, it is from, hang on. I think it's supposed to, yeah, from cap to, I believe they call it B. You should read nothing. I got my meter set on ohms. And I'll get in there like so, and go here like so. Yeah, I'm reading like 13 meg. You're supposed to read nothing from there to there. And then from what you would perceive as a normal coil, where you go from B to line or L1, you get continuity. On this relay, it's kind of different, but you can read the schematic on the side of the relay if you don't know what to do. But from here to here, you read continuity. And then from here to here, you're going to read like 5K ohms. And then you're going to read this capacitor here is supposed to be like 125 max. The way to do that, you guys set your meter up to be ready for it, but I've got capacitor reading here. Reading large capacitors like this will drain your 9-volt battery pretty easily, but just stay on there just as long as you need to. So I'm going to go, polarity isn't going to matter for us right now. It's going to go to an open state. It's stealing juice from your 9-volt battery, but it's going to give us a reading. 120 microfarad. Okay, there we go. We got that one. So this relay is acting up. It's not passing test for here to here, and I documented that right there. I'm gonna slowly. These are my readings. If anybody's got any questions on their pump and how it's failing, give me an email. Pause as you see fit. Here's a capacitor here that has a probably like a CLR, like a current limiting resistor across, or an RC. Maybe it's a time constant kind of thing. I don't know what size that is. It's brown, green, orange. Okay, so brown is 1 and the green is brown. Yeah. 1, 5, and then orange is 3. So that's 15,000 ohm, 15k ohm resistor across the terminals of the capacitor. And it's supposed to be 86 microfarad. I believe it's reading a little bit higher than that. It was plus or minus 20%. What's wrong? Come on. Oh, that's what's going on. Hang on. The whole daggone capacitor was moving. It's reading 109 microfarad. And it's clearly labeled an 86, but plus or minus 20%. And that might be close enough. Okay? Hang tight. We'll get back to this, which is very important. You'll see that right here, L1 and L2, and your ground is where you're coming in from your pressure switch. That means power travels through this common set of contacts up to these two tangs here. And these two tangs are occupied by the blue and the yellow. And the yellow jumpers over, and it takes in L2. And the blue goes up to the coil of the relay right here, goes across the coil and comes back on L1, and then it does its thing with the reed switch and the triac, and the output of it is right here on the orange wire. It goes to one side of the capacitor and goes through the capacitor and comes out on one of your legs going to the pump. So these 3 legs here, it's oriented proper. It's just the way this thing snaps in. Remember, this is a knockoff style. I don't know if it's knockoff or not. It looks like it's a pretty high quality part. There's the model number and everything if you're interested. This is up to 3/4 horse. I found mine at a local lumber store that sells plumbing as well. Okay. I would have picked up the QD panel if they had one in stock, but this is almost a spitting image of it. That one right there is close enough. But the relay is different. This relay has continuity on the contacts with it de-energized. This one I think develops continuity once it heats up, like it's got a heater circuit. These 3 terminals right here are the leads that go out to your pump. Your pump will be hooked up here as red, red, yellow, black. Okay? And you're going to have to look up what your general consensus is of what your expected readings are. But here I've got some little cheat sheet for you. This is called resistance right here. From red to black. From red to black, your expected readings are 1.7 to 2.2 k ohm. I'm getting 14k. Red to yellow, your expected reading is 8 ohms. I'm getting 140k. And remember, the cover is off, so the pump is isolated from this circuitry. It's just dongling in the wind. The pump is wired to here, here, and here. There's nothing else, so it's isolated. Yellow to black, you expect to get about, I think, 0.2 ohms. I'm getting 140k. I'm getting very high resistance right here on these two readings. And there is a gospel of well pump and pumps and control boxes called the AIM manual by Franklin Electric. And you'll focus on page 13 and 46 and 47. In the newer 2024 guide, it's page 13, and then I think it's, instead of page 46 or 47, I think it's 49 and 50 and 51. But it's based on the premise that you know what model your pump is and how many horsepower. Well, I don't know. And also, I don't have a traditional 3-wire pump, because when someone says 3-wire, that means you have 3 conductors, excluding the ground. Normally a 3-wire would be you just count your hot legs, your red, black, and yellow, and ground, and that would be 4 wires. But a 3-wire circuit is actually 4 wires. Don't count the ground, just ignore the ground, and that's how many wire you are. A lot of well pumps are just 2-wire, and you don't have a control box. That's because your pump is going to be much longer in size physically, because all of this stuff is integrated into the pump assembly. This is why you come up out of the well sleeve with 2 solid black conductors and a ground, and it's hooked directly up to your pressure switch. For higher horsepower type motors, they're going to be smaller in length, but they do not have these parts inside the pump. They are external. There's kind of a benefit there, because, you know, if you blow a capacitor, your lightning or your relay, they could prematurely fail earlier than the pump itself. You'll be pulling the pump out earlier. So that's a disadvantage to the integrated well pumps. Integrated meaning the control circuits are built into the pump. The longer pumps have, and if they're only 2-wire where they got a black and a green, those are designed to be simple, but you pay the price if you blew up a relay that's $14, or a capacitor that's 16 bucks. You're pulling your pump. It's your choice. I'm kind of in a pickle myself right now. I got to get water running and I'm doing this video. It's 19 minutes long. But that's your resistance readings. This is my readings with the power on for voltage, with this cover on, and using this tool called a power probe, where I was able to pierce the insulation and read. I was using 2 of those because I'm reading from one conductor to another. Power probes that hook up to your multimeter. They have a little stick pin integrated into them. You just slip it over the wire and twist this, and it has a real thin needle that pierces the wire. I was reading the output of my box, and this is Not the, this goes with this one. But I was reading the output going to the well pump, and for my voltages on my red and black output with power on, breaker on, I was getting 0 volts. Red to yellow, I was getting 240. Yellow to black, I was getting 240. And then from my red to ground, I was getting 120. Yellow to ground, 120. Black to ground, 120. So, it's really interesting. So you got your resistance readings. You got my voltage readings, which are a failing pump. You have my capacitor value, 125 microfarad, but you just got to be able to read capacitors and know if you've got to move your meter leads around to capture capacitance. Like on my meter, it tells me if I want to capture a capacitor. I see the symbol for a capacitor over here. If that's my common, I'm going to move my red lead over here to read amps or milliamps or microamps or capacitance. And then you've got my relay, my blue relay data. That relay. And then I've verbally told you this white relay acts the opposite. The coil on this white relay is right here. And it's like 5K ohms. And then the contacts are right here, the contact side. It acts like a normally closed, and it has continuity. Alright guys, 21 minutes. I'm working on my pump. I'll give you a quick cap on what I'm trying to do. Hang tight. So check this out. I got a steel bar. I've got an old lawnmower wheel. Put that on there like that. You guys see that? That's a pulley. It's not a car. It's not a lawnmower wheel. So hang tight. Since I live in a log house, I have scrap log, and I've drug one over here. But my plan is to lay 2 logs over top of the well house with that pipe, that metal bar, and that lawnmower rim secured to the 2 logs on the top side, centered over my well head, and brace these up, these 2 logs with on top the metal bar and that rim. I'm going to use that as the thing to pulley my pump tied to my Bronco and take it up here. That's about 90 feet. And right up there, I'm going to have a car rim laying on the ground with a pipe driven in the ground. And I'm going to drag the water line with the Bronco around that car rim and drive the Bronco that way. But as I make that turn, my pipe and wire is going to catch on that car rim, and it's going to act like a 90-degree turn for me. It's going to catch everything. I just drive the truck wide, make my turn. The car rim's going to catch it right in here. I'll drive that way and go all the way down the back of the yard as far as I want to get this 225 feet out. That's the plan. The other option is to arrange this pulley, and I go that way with my pipe work. I just got to move that boat out of the way, or I go below the boat, back my Bronco in over here, and drive down the driveway. I think going uphill is probably my better shot because it's more clear. I haven't decided yet. Alright guys, see ya. We're going to be doing part 2 on this, or 3, or 4. Bye. See ya.